You think physics explains the universe, and it does. Sort of. We understand gravity. We understand atoms. We understand the Big Bang. We've measured the age of the universe, its composition, its evolution. We know more about the cosmos than any previous generation in human history, but we don't know why it exists. Not even close. And the more you dig into what physics actually says about existence, the more uncomfortable you become. Because physics doesn't have an answer. Not a real one. Not a satisfying one. And worse, physics might be telling us that the question itself is wrong. Richard Feynman knew this. He spent his life thinking about the deepest questions in physics. And when asked about existence, about why there's something rather than nothing, he had no answer. Nobody does. And the attempts that have been made, the philosophical frameworks that have been proposed, they're all unsatisfying, all incomplete, all leaving you with more questions than you started with. Let me show you why this is so uncomfortable. Here's the question: why does the universe exist? Not how, not what. Why? Why is there something instead of nothing? Why are there laws of physics? Why is there space and time? Why is there existence at all? Most people turn to religion for this answer. God created the universe. That's the answer. But that's not a physics answer. And more importantly, it doesn't actually answer the question. It just pushes it back one step. Why does God exist? If God can exist without reason, without cause, why can't the universe? You've explained nothing. You've just added an extra entity, made the problem bigger, not smaller. Philosophy tries. The cosmological argument, the ontological argument, the argument from contingency, all trying to prove that something must exist, that existence is necessary, that nothing is impossible. But these arguments all have flaws, all make assumptions, all beg the question in subtle ways, and none of them explain why existence takes the form it does, why this universe and not some other, why these laws and not different laws. Physics can't answer why in the sense you want. Physics answers how. How does gravity work? How do atoms bond? How did the universe evolve? These are questions physics can address. Questions about mechanisms, processes, laws. But why questions? Questions about purpose, meaning, ultimate reasons. Those are outside physics. Physics describes what is, not why it is. Feynman was very clear about this. He said science doesn't answer why in the ultimate sense. It answers how. It finds patterns, laws, regularities. It makes predictions, but it doesn't give you purpose. It doesn't give you meaning. It doesn't tell you why there's something rather than nothing. It just tells you about the something that exists. But even limiting ourselves to how questions, we run into problems. How did the universe begin? The Big Bang. Okay, but what caused the Big Bang? What came before? And here's where physics starts to fail. Where our equations break down. Where our understanding ends. The Big Bang is a singularity, a point where density and temperature become infinite, where space-time curvature becomes infinite, where our equations give nonsense answers. Divide by zero. Infinity. Undefined. We can trace the universe back to a fraction of a second after the Big Bang, but we can't go further. The math breaks. The physics fails. There's a wall, and beyond that wall, we don't know. We can't know. Not with current physics. Some people say the universe came from nothing. Quantum mechanics allows it. Virtual particles appear from nothing all the time. But that's not nothing. The quantum vacuum is not nothing. It's a seething sea of quantum fields, governed by quantum mechanics, following laws. It's something. It's not nothing. Creating the universe from the quantum vacuum doesn't explain where the quantum vacuum came from, where the laws of quantum mechanics came from. You haven't explained existence. You've just described a mechanism within existence. Others say the universe created itself. It's self-caused. A quantum fluctuation created space and time, and that space-time allowed the fluctuation. But this is circular. How can something create the conditions for its own creation? You'd need time before time existed, causation before causation existed. It's logically problematic at best, nonsensical at worst. Some propose a multiverse, an infinite number of universes, all existing, all with different laws, different constants, different properties. Our universe is just one of infinitely many, and we exist in this one because it's the one that allows existence like ours. The anthropic principle. We observe this universe because it's the kind of universe that allows observers. But this doesn't answer the question, it just makes it bigger. Why does the multiverse exist? Where did it come from? What laws govern it? You've explained why our particular universe has the properties it does. Selection effect. We're here because we can be here. But you haven't explained why there's a multiverse at all. Why there's anything. You've pushed the question up one level, made it about the multiverse instead of the universe. But the fundamental question remains. Why something rather than nothing? Feynman didn't like this kind of thinking. He thought it was too speculative, too far from testable physics. The multiverse might exist, but if we can't observe other universes, if we can't test the hypothesis, is it science or is it metaphysics? Is it physics or is it philosophy pretending to be physics? He preferred to stay close to what we can observe, what we can measure, what we can test. And what we observe is one universe, this universe, with these laws, these constants, these properties. That's what we know. Everything else is speculation, maybe informed speculation, maybe mathematically consistent speculation, but still speculation. And even this universe, the one we can observe, we don't fully understand. We know it's expanding. We know it's 13.8 billion years old. We know it's mostly dark energy and dark matter. Things we can't see, can't detect directly, don't understand. We know 95% of the universe is something we know nothing about, and we're trying to explain why the universe exists when we don't even know what most of it is made of. Here's another uncomfortable truth. The laws of physics might be arbitrary. They might not have to be what they are. The speed of light, Planck's constant, the strength of gravity, the mass of the electron, all the fundamental constants. They might just be what they happen to be in our universe. No reason, no explanation, just brute facts. Or they might be connected. Maybe there's some deeper theory that explains why the constants have the values they do. Why these laws and not others? String theory tries to do this. Loop quantum gravity tries, other theories try, but none of them work yet. None of them make testable predictions. None of them explain everything. They're all incomplete, all speculative, all hoping that someday they'll be testable. But right now they're just math, elegant math, beautiful math, but unproven math. And even if we found a theory of everything, a final theory that explains all the forces, all the particles, all the constants, it wouldn't answer why. It would answer how. It would show how everything fits together, how the laws relate, how to calculate everything from first principles. But it wouldn't tell you why those first principles and not others, why that theory is real and other possible theories are not. You'd still be left with the fundamental question. Why does that theory describe reality? Why does anything exist at all? The theory would be powerful, predictive, testable, but not explanatory in the ultimate sense. Not answering why, just answering how more completely. Feynman thought this was okay. He thought physics is about finding patterns, not ultimate purposes. About describing reality, not explaining why it's real. About discovering laws, not justifying existence. And he was comfortable with that. He didn't need ultimate answers. He was satisfied with proximate understanding, with knowing how things work even if he couldn't say why they exist. But most people aren't satisfied with that. Most people want to know why. They want meaning, purpose, reason. They want the universe to make sense in human terms, to have a point, to be about something. But the universe doesn't owe you meaning. It doesn't owe you purpose. It just is. And physics describes what is, not why it is. Let me make this more concrete. Let me show you specific attempts to answer why does the universe exist and why they all fail. Attempt 1. God created it. Okay, why does God exist? If you say God is necessary, God must exist, then I ask, why can't the universe be necessary? Why add the extra step? And if God doesn't need a creator, why does the universe? You've explained nothing. You've just labeled your ignorance God. Attempt 2. The universe created itself. How? Self-causation is logically incoherent. Causes precede effects. The universe can't precede itself, unless you invoke some weird quantum thing where time is fuzzy and causation is unclear. But then you're not really explaining. You're just saying quantum weirdness allows it. That's not an explanation. That's an evasion. Attempt 3. The universe is necessary. It must exist. There's no possible world with nothing in it. Nothing is impossible. But why? What makes existence necessary? What prevents nothingness? You're asserting necessity without justifying it. You're saying existence must be because it is. That's circular. That's not an answer. Attempt 4. There are infinitely many universes. Ours is one of many. But why do infinitely many universes exist? Where did the multiverse come from? What laws govern it? You've multiplied the mystery, made it bigger, not solved it, and the multiverse is untestable. Maybe it exists, maybe it doesn't. We can't know. It's not physics at that point, it's metaphysics. Attempt 5. The universe fluctuated into existence from the quantum vacuum. But the quantum vacuum is not nothing. It's a quantum field in its lowest energy state. It has properties. It follows laws. It's something. You haven't explained where that something came from. You've just described a mechanism within something, not the origin of something. Attempt 6. Time began at the Big Bang. There is no before. The question, what came before, is meaningless, like asking what's north of the North Pole. There's no north of the North Pole. North ends there. Time ends at the Big Bang, or begins there. The question is ill-formed, but this doesn't explain why there's time at all, why there's a Big Bang, why there's existence rather than non-existence. It just says the question might be grammatically wrong. That doesn't make it go away. Every attempt fails. Every answer raises new questions. Every explanation requires more explanation, and you never get to the bottom. You never reach a final answer that doesn't require further justification. It's turtles all the way down, except we don't even know if there are turtles. We just know we can't see the bottom. Feynman would say that's fine. That's how it is. Some questions don't have answers. Some mysteries are irreducible. Some things just are. And being comfortable with that, accepting that, not making up stories to fill the gap, that's intellectual honesty. That's scientific maturity. That's what it means to really understand the limits of understanding. But it's uncomfortable. Deeply uncomfortable. We want answers. We want closure. We want everything to make sense, but the universe doesn't care what we want. The universe just is, and we're left wondering why. Now let me tell you about something even more disturbing. The fine-tuning problem. The universe seems incredibly fine-tuned for life. Change the strength of gravity by 1 part in 10 to the 40th, and stars don't form. Change the electromagnetic force slightly, and atoms don't bond. Change the mass of the electron, and chemistry doesn't work. Change the cosmological constant, and the universe either collapses immediately or expands so fast that matter never clumps into galaxies. The fundamental constants of nature seem precisely calibrated to allow complexity, to allow stars, planets, chemistry, life. Change any of them slightly, and you get a sterile universe. No structure, no complexity, no us. This is disturbing, because it looks designed. It looks like the universe was set up specifically to allow life. But by whom? By what? The anthropic principle says we observe these values because we're here. We couldn't be here if the values were different. So of course we observe life-friendly values, selection bias. We're in the universe that allows us. But this feels like cheating. Like explaining why you won the lottery by saying someone had to win and it happened to be me. True. But it doesn't explain why the lottery exists. Why the rules are what they are. Why winning was possible at all. The multiverse tries to solve this. If there are infinite universes with different constants, then some will have life-friendly values. We're in one of those. Not because of design, but because of statistics. Infinite rolls of the dice. Some come up with the right numbers. We're in one of those. But again, this doesn't explain the multiverse. Doesn't explain why there's a dice rolling mechanism at all. Doesn't explain the meta laws that govern the multiverse and allow different universes with different constants. You've solved one problem by creating a bigger one. And here's the really disturbing part. Maybe there's no explanation. Maybe the constants just are what they are. Brute facts, no reason, no cause, no explanation. Just, that's how it is. And we have to accept that. We have to be okay with fundamental inexplicability, with mystery at the base of everything. Feynman was okay with this. He didn't need the universe to make sense in human terms. He didn't need purpose or meaning or design. He was content to describe what is and accept that some questions might not have answers, that some things might just be. And that's not a failure of understanding. That's recognition of the limits of explanation. But for most people, this is intolerable. This is the opposite of what they want. They want meaning. They want purpose. They want the universe to be about something. to have a point, to make sense. But what if it doesn't? What if it just is? What if existence is a brute fact with no explanation? Let me tell you about one more attempt, one more try at answering why does the universe exist? And it's the strangest one of all. Maybe the universe exists because it's mathematically possible. Mathematical structures exist platonically, in some abstract sense. The integers exist. Geometric shapes exist. They're discovered, not invented. They're real in some sense, even if they're not physical. And maybe the universe is just a mathematical structure. And it exists because mathematical structures exist. It's possible. So it's real. This is Max Tegmark's mathematical universe hypothesis. The idea that physical reality is mathematics. That the universe is a mathematical object. That existence is just mathematical consistency. If something is mathematically possible, it exists. And our universe is one of infinitely many mathematical structures that exist platonically. But this is bizarre. This makes existence incredibly cheap. Everything that's mathematically consistent exists. Every possible universe, every possible mathematical structure, that's a huge ontology, an infinite number of existing things. And it doesn't explain why mathematical structures exist in the first place, why Platonism is true, why mathematics is real rather than invented. You've pushed the mystery to mathematics, but the mystery remains. Feynman would have been skeptical. This is very far from testable physics. It's philosophy. It's metaphysics. It might be true. It might not. We have no way to know. And claiming that untestable philosophical speculation is the answer to why does the universe exist is overreach. It's going beyond what we can know, beyond what physics can tell us. Here's the pattern. Every attempted answer either pushes the question back one level or makes untestable metaphysical claims. No attempt actually explains why there's something rather than nothing. No attempt reaches a stopping point that doesn't require further explanation. No attempt satisfies. They all leave you unsatisfied, uncomfortable, still wondering. And maybe that's the point. Maybe the question is unanswerable. Maybe there is no why. Maybe existence is a brute fact, the ultimate brute fact, the thing that just is without reason or cause or explanation. And everything else flows from that. All the structure, all the laws, all the complexity. It all emerges from the brute fact of existence. But existence itself is unexplained, inexplicable, irreducible. This is what Feynman understood. This is what made him different. He was comfortable at the boundary, comfortable with mystery, comfortable saying, I don't know, and not filling the gap with stories, not pretending to knowledge he didn't have, not trading intellectual honesty for emotional comfort. Most people can't do this. Most people need answers, need closure, need meaning, so they make up stories. God, purpose, design, necessity, self-causation, mathematical existence, whatever fills the gap, whatever makes them feel better. But none of it is justified. None of it is proven. None of it is physics. It's all just attempts to avoid the discomfort of not knowing. And here's the deepest discomfort. Maybe the question itself is wrong. Maybe why does the universe exist is like asking what color is Tuesday or how much does freedom weigh. Maybe it's a category error, a grammatically correct sentence that doesn't actually ask anything meaningful. Maybe why doesn't apply to existence itself. Maybe existence is the kind of thing that doesn't have a why. That just is. And asking for a reason is asking for something that doesn't exist. This is the most uncomfortable answer of all. Not we don't know yet, but the question is meaningless. Not we haven't found the answer, but there is no answer because there's no question. Not ignorance, but category error, grammatical confusion mistaken for deep mystery. Feynman thought this was possible. He thought many philosophical questions are like this. They sound profound, but they're actually confused. They're asking for something that doesn't exist, like asking for the sound of one hand clapping, or the color of a dream, or the weight of an idea. These questions sound meaningful, but they're not. They're confused. They're mixing categories that shouldn't be mixed. Maybe why does the universe exist is like that. Maybe we're treating existence like it's the kind of thing that has reasons, but maybe it's not. Maybe existence is more fundamental than reason, more basic than causation, more primary than explanation. Maybe it's the ground floor, the thing everything else rests on, but which itself rests on nothing, needs nothing, explains nothing, just is. And if that's true, then physics has no answer. Not because physics has failed, but because there's no answer to have. The question is wrong. The category is confused. We're asking for something that doesn't exist, and the discomfort comes from realizing that our deepest question might be a mistake. This is where Feynman lived, at the boundary between knowledge and mystery, between answerable questions and category errors, between science and philosophy. And he was comfortable there. He didn't need answers to unanswerable questions. He didn't need to pretend confused questions were profound. He was okay with limits, with boundaries, with not knowing, with possibly never knowing. But he also knew what we do know. And that's astonishing. We know the universe is 13.8 billion years old. We know it started in a hot, dense state and expanded. We know the laws that govern its evolution. We know how stars form, how galaxies cluster, how planets coalesce, how chemistry works, how life evolved. We know so much, more than any previous generation, more than we ever thought possible. We just don't know why any of it exists, why there are laws, why there's space and time, why there's something rather than nothing. And maybe we never will. Maybe that's beyond physics, beyond science, beyond human understanding. Maybe that's where explanation ends. Not at an answer, but at the recognition that some questions don't have answers. That's uncomfortable, deeply uncomfortable. We want closure. We want understanding. We want everything to make sense, but the universe doesn't owe us that. The universe just is, and we're part of it, trying to understand it, making progress, learning more, but never reaching the bottom, never finding the ultimate answer, always left with one more question, one more mystery, one more why. And maybe that's okay. Maybe that's how it should be. Maybe the fact that we can ask these questions, even if we can't answer them, is enough. Maybe the fact that we're here, conscious, aware, questioning, wondering, is itself remarkable. Maybe existence doesn't need justification. Maybe it's enough that it is, that we are, that the universe is here to be wondered about. Feynman thought so. He thought the universe is more wonderful, more beautiful, more astonishing than any story we could make up about it. He thought mystery is better than false certainty. He thought not knowing is better than pretending to know. He thought honest confusion is better than comfortable lies. And he was right. The universe exists. We don't know why. We might never know why. The question might not even make sense, but we can know how. We can understand the laws. We can make predictions. We can test theories. We can explore. We can discover. We can be amazed. And that's enough. That's more than enough. That's everything. So why does the universe exist? Physics has no comfortable answer, no satisfying answer, no complete answer. Just we don't know. Just maybe the question is wrong. Just it is, and that's all we can say. And you have to be okay. With that, you have to accept that. You have to live with the discomfort, because that's reality. That's honesty. That's what it means to really understand the limits of understanding. Welcome to the boundary. Welcome to the edge. Welcome to the place where all explanations end and only mystery remains. It's uncomfortable here, but it's honest. It's real. And it's where physics has always been leading you. To the recognition that some questions don't have answers. Some mysteries are irreducible. Some things just are. And that's not a failure. That's the beginning of wisdom. But let me be more specific. Let me tell you about actual physics proposals for why the universe exists and why they all fail to satisfy. Stephen Hawking proposed the no boundary proposal with James Hartle. The idea is that time is like space near the Big Bang. It doesn't have a beginning in the usual sense. If you go back far enough, time becomes space-like. It curves around. There's no edge, no boundary, no beginning, no before the Big Bang, because there's no time coordinate that's before. It's like asking what's south of the South Pole. Nothing is south of the South Pole. That's where south ends. This is elegant. This avoids the problem of what came before. There is no before. Time and space emerge together in a smooth four-dimensional geometry with no boundary, no singularity, no edge, no beginning that requires a cause. But it doesn't answer why. Why does this geometry exist? Why does space-time have this shape? Why are the laws such that this no boundary condition is possible? You've described a mechanism. You've shown how the universe can exist without a temporal beginning, but you haven't explained why it exists at all. Why this geometry rather than none? Why something rather than nothing? John Wheeler, Feynman's mentor, proposed something even stranger: the participatory universe. The idea that the universe doesn't exist until it's observed, that quantum mechanics requires observers to collapse wave functions, that the universe is participatory. It needs consciousness to become real. We create reality by observing it. The universe exists because we observe it existing. This is deeply weird, and it doesn't actually work. Because who observed the universe before humans existed? Before life existed? Before Earth existed? Did the universe not exist for 13.8 billion years until the first conscious observer? That's absurd. Quantum mechanics doesn't require conscious observers. It requires measurement, decoherence, interaction with the environment, and that happens all the time without consciousness. Wheeler later backed away from this idea, but it shows how desperate physics gets when trying to answer, why does the universe exist? We start proposing that consciousness creates reality. That observation is fundamental, that the universe needs us to exist. It's flattering, but it's almost certainly wrong. And even if it were true, it doesn't answer why. Why does observation create reality? Why are the laws such that this is possible? Why is consciousness fundamental? You've just moved the mystery to consciousness. Alexander Vilenkin proposed that the universe tunneled into existence from nothing. Quantum tunneling. A particle can pass through a barrier it doesn't have enough energy to overcome. It just appears on the other side. Probability. Quantum mechanics. No violation of energy conservation because it's temporary, borrowed from vacuum fluctuations. Vilenkin says the universe did this. It tunneled from nothing into something. No cause, no reason, just quantum probability. Given enough time, even incredibly improbable things happen, and the universe is an incredibly improbable quantum tunneling event that just happened. But again, this assumes quantum mechanics. It assumes the laws of quantum tunneling. It assumes a quantum vacuum, even if that vacuum is nothing in some technical sense. It's not explaining existence. It's explaining how existence could arise within a framework that already exists. The framework of quantum mechanics, the framework of physical laws, and that framework is something, not nothing. Where did it come from? Lee Smolin proposed cosmic natural selection, the idea that universes reproduce through black holes. Each black hole creates a new baby universe with slightly different constants. Universes with more black holes produce more offspring. Natural selection operates on universes. Our universe is fine-tuned because it's descended from many generations of universes optimized to produce black holes. And producing black holes happens to also allow life. This is creative. It's testable in principle. We could check if universes optimized for black holes match our observations. But it doesn't explain the meta-universe, the space of all possible universes, the mechanism of black hole reproduction, the laws that govern cosmic evolution. You've explained why our universe has the properties it does. Selection effect. But not why there's a system of reproducing universes in the first place. Where did that come from? Every physics proposal does this. It explains one thing by assuming something else. It answers one question by raising another. It pushes the mystery back, but never eliminates it. And eventually, you reach a point where physics has nothing to say, where explanation ends, where you just have to accept brute facts, unexplained starting points, irreducible mysteries. And here's what's really uncomfortable. Religion offers a stopping point. God. God is the uncaused cause, the necessary being, the thing that needs no explanation. God just exists, necessarily. And God created everything else. It's clean. It's simple. It's satisfying emotionally. It gives you a stopping point, an answer, closure. But it's not a physics answer. And it's not actually explanatory. You've just labeled your ignorance, called the mystery God. But you haven't explained anything. You've just declared that one thing doesn't need explanation. And if you're going to do that, why not just say the universe doesn't need explanation? Why add the extra step? Why multiply entities? The religious answer is comfortable, but it's not honest. It's a story we tell ourselves to avoid discomfort, to avoid living with mystery, to avoid admitting we don't know. And Feynman rejected comfort in favor of honesty. He'd rather not know than pretend to know. He'd rather live with mystery than believe comfortable lies. This is what makes the physics answer so uncomfortable. Physics doesn't give you comfort. It gives you honesty. And honesty means admitting limits, admitting ignorance, admitting that some questions might not have answers. That's hard. That's unsatisfying. That's uncomfortable. But it's real. It's true. It's what intellectual honesty demands. Now let me tell you what we do know. Because focusing only on what we don't know gives a false impression. We know a lot, an astonishing amount. We might not know why the universe exists, but we know an incredible amount about how it works. We know the universe is 13.799 billion years old, plus or minus 0.021 billion years. We've measured this, multiple independent methods, all converging on the same answer. That's not speculation. That's knowledge. We know the universe is expanding. We measure the redshift of distant galaxies. We see them moving away. The farther they are, the faster they recede. Hubble's law, confirmed millions of times. We know the expansion rate. We know the acceleration. We know the history. We know the universe was hot and dense in the past. We see the cosmic microwave background, the afterglow of the Big Bang. We measure its temperature, 2.725 Kelvin. We measure its fluctuations. We see the seeds of galaxy formation. We predict what we should see, and we see exactly that. We know the composition of the universe. 5% normal matter, 27% dark matter, 68% dark energy. We don't know what dark matter and dark energy are, but we know they're there. We measure their effects. Gravitational lensing, galaxy rotation curves, cosmic expansion. The observations are clear. The mystery is what they are, not that they're there. We know the laws of physics, quantum mechanics, general relativity, the standard model of particle physics. These theories work. They make predictions. The predictions match observations to incredible precision, parts per billion, parts per trillion. These are not guesses. These are tested, confirmed, reliable theories. We know how stars work. Nuclear fusion. We can calculate the lifetime of a star from its mass. We can predict its evolution. Red giant, white dwarf, or supernova, neutron star, black hole. We see these predictions confirmed over and over in millions of stars. We understand stellar evolution. We know how galaxies form. We simulate it. We watch it happen in the early universe through telescopes. We see galaxies at different stages of evolution. We understand structure formation, dark matter clumping, gas, cooling, star formation. It matches our models, our predictions, our understanding. We know how planets form. We've seen it. Protoplanetary disks around young stars. Planets forming in real time. We understand the process. Dust to pebbles. Pebbles to planetesimals. Planetesimals to planets. We've found thousands of exoplanets. We see the diversity. We understand how it arises. We know how life evolved on Earth. We have the fossil record. We have DNA evidence. We have molecular clocks. We understand the tree of life. Common descent, natural selection, mutation, drift, speciation, the mechanisms, the timeline, the relationships. It's all there. All confirmed, all understood. We know so much, more than any previous generation imagined possible. We've explained stars, galaxies, planets, life. We've understood the history of the universe from seconds after the Big Bang to today. We've measured the composition, the age, the evolution. We've tested our theories to incredible precision. We've built technology based on our understanding. Technology that works, reliably, predictably. All of this is knowledge. Real, tested, confirmed knowledge. Not speculation, not guesses, not myths. Knowledge. And it's astonishing, beautiful, profound. It reveals a universe more wonderful than we imagined, more elegant, more comprehensible, more amazing. But it doesn't answer why. Why these laws? Why this history? Why existence at all? And that's the discomfort. We know so much about how, but nothing about why. And we might never know. Because why might not be a physics question. It might not even be a coherent question. Feynman celebrated what we know. He marveled at the beauty of physics, the elegance of the laws, the power of understanding. He thought the fact that we can understand the universe at all is remarkable, that we can discover these patterns, test these theories, make these predictions. That's incredible. That's worth celebrating. But he also accepted what we don't know, what we can't know, what might be unknowable. And he didn't see that as a failure. He saw it as honesty, as realism, as intellectual maturity. Knowing the limits of knowledge is itself knowledge. Knowing what you don't know is wisdom. Accepting mystery without filling it with false certainties is integrity. This is the heart of the discomfort. We're creatures who want answers, who need closure, who crave meaning. And the universe doesn't give us that. It gives us patterns, laws, regularities, beautiful, elegant, powerful patterns, but not meaning, not purpose, not ultimate explanations. And accepting that, living with that, being comfortable with that, that's hard. That's the work. That's the challenge. Most people can't do it. Most people need the comfort, need the stories, need the answers, even if they're not real answers. God, purpose, design, meaning, necessity. They need something to fill the gap, something to make it make sense, something to avoid the discomfort of mystery. But Feynman shows us another way, the way of honesty, the way of accepting limits, the way of celebrating what we know while admitting what we don't, the way of finding beauty in patterns without needing ultimate meaning, the way of being human in a universe that isn't about us, doesn't care about us, doesn't owe us explanations, just is. And that's where physics leads, not to comfortable answers, but to honest mystery, not to certainty, but to wonder, not to ultimate explanations, but to the recognition that some things just are. And that's not a failure of physics. That's physics being honest about its limits, about what it can do and what it can't, about where explanation ends and mystery begins. So why does the universe exist? We don't know. We might never know. The question might not even make sense, but we can marvel at the fact that it does exist, that we're here to wonder about it, that we can understand as much as we do, that the universe is comprehensible at all. That's the miracle. Not that it has a reason, but that it exists and we can understand it, even if we can't explain it. That's Feynman's answer. Uncomfortable, honest, real. No false comfort, no pretend certainty, no made-up stories, just it is, and we can understand how, but not why. Just mystery is okay. Just not knowing is better than false knowing. Just the uncomfortable truth that physics has no comfortable answer, and never will. And that's okay. That's how it should be. That's reality. And reality is enough.